Welcome to the first volume of The Science Bros, where Mr. Jeffers and myself, Mr. Hendershott, you can call me Hendo, we're going to put some fantastic science demonstrations and just fun science cool things where you can enjoy, ask questions, and we will respond if you send us an email or anything like that. And the first one is we are going to show you the reactivity of the alkaline metals and the alkaline earth metals. So the alkali metals is column 1 here, and the second column is the alkaline earth metals. Okay, so metals are on the periodic table this side over here and non-metals over here. All right, well, we are going to do today these 4: sodium, potassium, magnesium, and calcium. And we're going to do it in this order. We're going to do magnesium and then calcium, and then we'll do sodium and potassium. And we're going to talk about the reactivity. As we go down a column for the metals, they will get more reactive, at least for the alkali and the alkaline earth metals. So calcium will be more reactive than magnesium, and sodium will be more reactive, or potassium will be more reactive than sodium, okay? Because as you go down, you get more reactive. And you're going to find as we go this way to the left, you're also going to have more reactivity. So sodium will be more reactive than magnesium, and potassium will be more reactive than calcium. So to recap, go down, more reactive, and as you go left, more reactive. So we predict from that the least reactive will be magnesium, and the most reactive will be potassium. So let's take a look. All right, demo number 1. So magnesium is first on our list of elements to try. What we're going to do is we're going to put them in water and see how they react. And we'll talk a little bit about the reaction as they're going on. Okay, so first, if we have magnesium here, we are going to, I cut a strip, just took a piece of it, cut it with scissors. And if you want, you can look, and I can poke at it. It doesn't make like too much of a dent, so it's not super hard, but it's also not super soft, as you'll see in some of these other metals. And so this is just a simple strip of magnesium. And what we're going to do is we're going to put it in here. All right, drop it in the water. Like waiting. I know what you're saying. That is super lame. It's not doing anything. Well, it actually is oxidizing, and if I had a piece of it that had been oxidized in the water for a longer period of time, you'll notice it'll blacken, and that it will slowly corrode or change in colors, indicating that we had a chemical change. When you have a change of colors, a chemical change has occurred. So the magnesium will oxidize, taking oxygen from the air or the water, and it will do that. So, but that was not too exciting, but we all need a frame of reference. So I talked to my kids about in relationship to what, in relative to what. A frame of reference is very important in physics and chemistry. And so this is our reference right there. It's not super exciting, but it gives us the standard now that which we can compare the other elements to, okay? So on to the next one. All right. On to the next one, which is calcium force. That is down 1. So I'm just going to put some gloves on, and we're going to get out some of this. And here we go. As you can see, we have it. It is dull, and you can look at it, and you can see that it is oxidized a bit in the air. And we can put a few of these chunks in the water. And immediately you can see evidence of a chemical reaction occurring. Okay, now you're going to notice something pretty spectacular. What is being liberated there? Why is that burning? So the metal is not burning, but what we have is, as the metal, the calcium, reacts with the oxygen in the water. Well, what is water? It's H2O. Well, if you take the oxygen away from H2O, what are you left with? H. Hydrogen. Hydrogen forms diatomic molecules, which means there's 2 hydrogens packed together when it goes into the air. And so what happens is that hydrogen is being released, And as we all know, one of the properties of hydrogen is that it's combustible. So when I provide the flame, oxygen is provided by the air, and so the hydrogen, H2, plus O2 from the air, and the ignition source, and we get burns. And ironically enough, guess what is made in that reaction? Water. Pretty cool. All right, on to the next one. One of my favorites actually is sodium. So now we're moving to the left on the periodic table. And this will be more reactive than magnesium, but will it be more reactive than calcium is your question. So as we go to the left, we get more reactive, and as we go down, we get more reactive. So the question is, will it be more reactive than the calcium? So let us see. So first, I want you to notice, what am I taking this out of? It is in what is kitty litter. It's stored in kitty litter. Well, what is kitty litter good at? It is very good at absorbing moisture. The moisture from the air this stuff will react with it so readily that we have to store it in kitty litter. Now, also there's a liquid in there. Ooh, what liquid is this? Well, this is not water. If this was water, there would be no sodium left in here. But as you see, it's grayish, and I'm gonna stab it. Look at that. One of my dull scalpels, even rusting a little bit, and I stabbed the metal. I know it's not common, not ordinary to think of a metal as being soft, but this metal is soft. As you watch, I will cut it. Now, as I cut it, there we go. Look, it's shiny because that inside part has not oxidized with the air yet. So that is what the metal looks like, shiny, and it is soft. Now, back to the question of what is in this. What is in here? This is mineral oil. So even though this sodium is stored in mineral oil, stored in kitty litter, it still oxidizes. And it's doing so now. If you look, it's already starting to become a little less shiny. And so you can see that even under these conditions, that this is oxidizing. Pretty special. And so already you're starting to get excited. I am too. That this will be better than calcium. All right. So, taking appropriate safety precautions, we have my goggles on, have my gloves, and we're going to see what this is, how this reacts. I'm going to light it. It's pretty cool to think that water is causing fire. Boggles the mind. But what is happening? The sodium is reacting with the oxygen in the water, creating hydrogen. The hydrogen is reacting with the oxygen in the air, and with my ignition source, it's burning. It's turning back, it's creating water. So it's just a pretty cool little circle there that's what's happening with it. And I wanted you to also pay attention to the orange flame that it was. That's a telltale sign of the metal that is burning. There is something called a flame test, which different metals will burn at different colors. And it's why we get fireworks of brilliant different colors. We have different metals in there. And what we can do here is we can kind of identify with that. We can identify the element from the color of it. So that one was orange. You're like, well, that didn't look no different than my normal fire. Well, you'll see in the next one, the potassium, a slightly different color. That's one of my favorites as well. All right, the last one. The excitement is building, and we've got potassium next, the next up on our list. and the last one that we have access to. And it's pretty spectacular. So as we go down, we get more reactive. As we go to the left on the periodic table, we get more reactive. So of the four, of that block of four, this will be the most reactive. Okay, so stored under mineral oil again, and in kitty litter. These are pre-made chunks. We are not going to cut the chunks. It is safer if you do not cut these. And look how black that is. It is oxidized quite a bit under the conditions of the oil and the kitty litter. And this one will self-ignite right almost instantaneous. What I want you to do is pay attention to the color, because you'll see a specific color that potassium burns at. Okay, here we go. See the purplish flame? There is a slightly purple flame. And that is it. That quickly reacted and producing potassium hydroxide and liberating hydrogen, and we're burning the hydrogen off. So once again, it's the reactions of the alkali metals. Your next question will be, well, what about other ones? Can we go down the periodic table? Well, the trend does continue. Sadly, we do not have access to rubidium and cesium, and definitely not francium. So thank you for this, and I look forward to seeing I look forward to seeing you guys again and doing more Science Bros videos.